Hey guys, I'm Teacher Maria, and for today's video, join me as I teach my first ever math lesson. And for today's lesson, we were going to talk about the 6 circular functions. So we have this circle in a plane, and the center is at the origin. And from the center to any point of the circle is called radius. So if we draw a line perpendicular to this x-axis, so we have this triangle x, y, and r. And the angle of this triangle is always with this x-axis. Then if we're going to pull out this right triangle, so we have this triangle x, y, and r, and this is our angle theta. Y is the opposite, x is the adjacent, and r is the hypotenuse. Then to solve for the 6 circular functions, so we have this sine theta, opposite over hypotenuse, that is y over r, cosine theta, adjacent over hypotenuse, that is x over r, tangent theta, opposite over adjacent, that is y over x, cotangent theta, that is adjacent over opposite, that is x over y, secant theta, hypotenuse over adjacent, that is r over x, and the cosine theta, that is hypotenuse over opposite, and that is r over y. So these are the 6 circular functions. So to solve for the unknown side or the missing side, we are going to use this Pythagorean theorem. The c squared equals a squared plus b squared since our variable x, y, and r. So we are going to use this formula to solve for the unknown side. That is r squared equals x squared plus y squared. And remember, r is always positive because r is the hypotenuse.
So we have here if cosine theta is equals to negative 12 over 13 and cotangent theta is greater than 0, find the values of the other circular functions of theta. Now from the given, we have this cosine theta and formula for cosine theta, that's x and r. Then we have this negative 12 over 13, so therefore x is equals to 12 and r is 13. Now since we have this negative, and this r is always positive, so therefore this negative is negative 12. Then y is unknown. So to solve for y using this formula, r squared equals x squared plus y squared. Then transpose this x squared to the left, that becomes r squared minus x squared equals y squared. Then substitute the value of r, that's 13. Then for the x, that's negative 12. Then this 13 squared, that's 169, and negative 12 squared, it's negative 144. Then 169 minus 144, it's 25. And to solve for y, take the square root. So y now is positive and negative 5.
Now to solve for the sine of y, we need to check if y is positive or y is negative. So from this given, we have this condition that cotangent theta is greater than 0. Since greater than 0, so this cotangent theta is positive.
In a plane under quadrant 1, all functions are positive. Under quadrant 2, only sine and cosine theta are positive. Under quadrant 3, only tangent and cotangent are positive. And under quadrant 4, only cosine and secant theta are positive. Again, cotangent theta is positive, so therefore, it's either in quadrant 1 or in quadrant 3 because given, since x is negative and in quadrant 3 x is negative, therefore theta is under quadrant 3. And in quadrant 3, y is negative. So therefore, y is negative 5. We can solve the remaining circular functions. Theta, that is y over r, that's negative 5 over 13. Tangent theta, y over x, that's negative 5 over negative 12. Negative divided by negative, that will be positive 5 over 12. Cotangent theta, x over y, that's negative 12 over negative 5 divided by negative positive 12 over 5. Secant theta, that is r over x, that is 13 over negative 12, r over x, that will be negative 13 over 12. Cosecant theta, r over y, that's 13 over negative 5, and that will be negative 13 over 5. So these are the remaining functions.
And that's it for today. Thank you for listening, and I hope you learned something today. Again, I'm Teacher Maria. Thank you for joining me. Stay tuned for our next math lesson. Bye bye. Have a good day.